Thanks, Facebook. So, if you were there for the first part, please come back. Please post up your name and company name in the comments. Please share the new feed, like the new feed, and we'll hopefully get rolling here. So I was in IMTS. I was looking at 5-axis robots, trying to figure out if they would be a good solution for polishing, buffing, and deburring on holster shells. I think it can work. They really seem to be geared more toward working with metal parts. Because our plastics are pretty soft, the interaction, the interface between the actual part and the wheel has to be very precisely dialed. Otherwise, you're actually going to grind the edge and change the profile. Hello, JR. Hello, Ben Miller. Welcome back, Shane Muse. Hi, Booth. And so I was looking at those. Talking about comments. Yeah, I do want to be able to answer questions, though, Nathan. That's part of this, is being able to give guys immediate feedback. I'm sure there'll be a part 2 and probably a part 3 on CNC, but I at least want to take a shot at answering questions in real time. So, for what I was looking at with the CNC, with the computer control robots, stuff was really expensive. Basic integrations of a single robot started around $100,000, at least for the kind of thing I was looking at, which would be not necessarily a bad investment, but a heavy investment up front. Hello, Clark. Hi, Robert. Hi, Conrad. I have 2 words to say on Fanuc. No. No. I'm sure you'll love your Duzan. I checked out their booth. They had some pretty awesome stuff there at IMTS. Hello, Mike. So, CNC, what is it? What is it good for? Why should holster makers consider getting into it? And what are the costs involved? Here we go. So, CNC stands for Computer Numerical Control. It just means that you're controlling motors and axes and driving parts around using computer coordinates. Basically, X, Y, Z coordinates. X side to side, Y down the table, Z up and down. Pretty basic stuff, but it can get into incredible levels of complexity. Hello, Tyler. And there are 2 basic large categories of things you can do with CNC in holster making. The first thing is make tools, jigs, fixtures, use CNC to make stuff to make holsters. And the second big category is use CNC directly to make holsters. So a few things in the first category would be mold tooling, jigs for drilling, any other kinds of tricks, special blocking, anything you make with the CNC that isn't itself part of the holster is a jig, a fixture, a piece of tooling. CNCs are great for that. You can lay out very precise hole patterns, make yourself nice drill guides. You can make jigs for folding. You can do all kinds of stuff to eliminate inconsistencies, to improve the results of your process. Tons of stuff you can do with jigs and fixtures. The big part, though, that attracted me was the possibility of actually using CNC to delete whole steps out of my existing process by trimming and drilling the parts and then going straight to a buffing wheel, no longer having to sand them to shape. And that's what I do primarily with, that's what holsters do, that's what I do with CNC for my holster work. I trim parts, I drill parts, I skip steps in the process by doing that. So when people are talking about CNC, CNC includes everything from a small 12 by 12 inch desktop unit that you're running off your laptop, where the actual cutter head is a Dremel or a 1 horsepower laminate trimmer router, a little handheld guy. That's CNC. CNC goes all the way up to the 80 or 90,000 pound machines I was seeing at IMTS that can machine a steel workpiece the size of a car. You know, everything in between, that's all CNC. But for holster makers, generally we're looking at 2 basic kinds of machines: small format CNC routers and small format mills. The major difference is generally in a router, the work stays still and the cutter head moves in X, Y, and Z. In a mill, typically the table moves in X and Y, the cutter head goes up and down in Z, and you make your cuts by a combination of movements of the head and the table. Okay? The advantage of a router is typically you can get a larger work area at for less cost, and overall routers are much less expensive than mills. Mills are substantially heavier duty, have a lot more torque, usually a lot more power, and can have other features like an auto tool changer to automatically change bit to bit, can have coolant for working with metals, and can come with a full sheet metal enclosure so when you use the coolant you're not spraying the mess all over your shop. Routers tend to have an open table and are commonly connected up with dust collection. That can be a shop vac, it can be an actual dust collector with a 4-inch or a 6-inch hose to suck up all the chips the router is making. I have both. I have a router and a mill. I use my router for trimming parts. I use my mill for making molds. The mill is able to machine at a much higher level of precision and a lot faster. The router is not as precise, not as quick, doesn't produce as nice a result when it comes to molds. And my router does not have a tool changer. So anytime I have to change bits, I have to stop the machine, turn it off, manually loosen the collet, take the bit out, put the next one in, reset the Z0, and then finish machining my part. So it's much more time consuming to use. My mill has a 21 tool changer, so I can write all the tool changes into the program, and the mill just selects the correct tool, loads it in, cuts till it's done, picks the next tool, and keeps going. So for mold making, and especially for making metal molds, aluminum molds, the mill is hands down the way to go. The trade-off is the price tag is way higher, to the order of roughly 10 times the price. So if you're thinking about getting into CNC, there are two large costs you need to wrap your head around up front. The first one is simply the dollars of the machine itself. You can get into a benchtop CNC, something like an X-Carve, for a little over, around $1,000, a little more, depending on how much you want to invest in a larger table, a heavier duty router. You can get into CNC routers like Probotics for a couple of grand. You can then you break into a second tier of slightly more professional grade machines, and that would be Cammaster, Shop Saber, some ShopBot machines, and then CNC routers that are in like the $8,000 to $20,000 range. And in that range, you can actually start to get a spindle, you can get a tool changer, you can get 4x4 or 4x8 feet of travel. You get a more robust machine with a built-in controller. It's a different animal than a $1,000 desktop that's built out of MDF, or some aluminum, some plastic, some MDF. If you plan to make lots of molds, or you plan to cut lots of parts and have the CNC running a lot of hours in the week, my recommendation is buy your second CNC first, skip the $1,000 one, and go to a more robust machine that's got more durable parts, it's got a heavier duty router on it, that can handle more hours, more use, and heavier cuts. Because if you buy one of those little desktop routers and you actually start to work with it and you start making good stuff, very, very quickly you will outgrow both the speed and the accuracy of that machine, and you'll wish you had something bigger. Now, this is always a balance that you have to figure out the cost benefit for your own shop. This is the cost versus value equation from the previous Facebook Live video. If you have no CNC experience, I would not recommend that you go out and spend $35,000 or $40,000 optioning out an industrial series Shop Saber 4x8 foot table with a 10 tool auto changer and like all the bells and whistles, because you will not be able to effectively use all that has to offer fast enough, probably. But for holster makers, for small shops of 1 to 5 employees, I think the sweet spot is probably machines that are 2x2 foot, 2x4 foot, maybe 4x4 foot. 4x8 foot machines are probably not what you want. Axiom Precision Routers, says John Keller. Never heard of them. There are a number of kind of unknown small CNC router manufacturers out there. If you're going to spend, if you're going to spend $4 or $5 grand on a router, buy from a company with a known track record. That's by Cammaster, by Shop Saber, by ShopBot. Velox CNC is another one that's a decent option. I went with a company called K2 CNC, and they went out of business 6 months after I bought my router. Poof, gone. Website down, sales staff laid off, nobody answering the phone. That was a huge, huge downside for me. I still have the router. I've had no problems with it. It works great. It makes parts. But if you go with a larger, more established business, you don't run the risk of suddenly being completely out in the cold and unable to get parts, unable to get service and support, unable to get your phone call returned if something goes wrong. So as you get into bigger and more expensive machines, be smart, protect your investment. Okay, saving $2,000 by getting a Chinese machine versus a U.S.-made machine, and then having a major problem with it you can't get resolved because it's manufactured overseas and you can't get a hold of anybody who built it, that very quickly becomes a loss. So you have the upfront cost of the CNC itself, then you've got software and accessories. Depending on what software and accessories you decide, those can get spendy. For software, hands down, far and away, my recommendation is Fusion 360 from Autodesk. It's a cloud-based integrated CAD/CAM solution, so you can do your 3D design and also your machine programming and tool pathing integrated into the same program. If you are a startup or a small company and you're making less than $100K a year, a subscription to Fusion 360 is free. It costs $0, and it is an incredibly powerful program. You can't beat it for that amount of money. Yeah, John Hoffman, I know you used a Probotics, and it cuts, but if you buy a CNC and your CNC is slow, every time you run it, you are throwing away more minutes every time. And if you can, get the cycle time down. So when I first started making molds on my little router, a mold took me a little over an hour to make. And that was with a couple tool changes. I was often starting out trying to do too much complexity. Now that I'm on my mill and I have the auto tool changer and I've gotten a lot better at programming, I can often make an HDPE mold in right around 10 minutes, slightly under sometimes, depending on the mold and its features. Glocks, super fast. Ones with some more complex angles and surfaces that have to be milled, like VP9, those take a little longer, like 14 minutes. Aluminum molds take longer than that. An aluminum mold is in the 25 to 30 minute range to go and get nice, clean surface finishes. But I can do that back to back to back to back to back. 1 hour on my router. That was Wren shape molds, Clark. I had to be a little more delicate with it than the HDPE because Wren shape is a little chippier. I don't use Wren shape anymore. I got tired of it. How does HDPE hold up to aluminum? John, there's no comparison between the two. The aluminum is a solid metal mold. It will last indefinitely. The HDPE is fairly soft. It's a little more user-friendly if you want to drill into it or modify it, but it's plastic. So HDPE molds have a limited life cycle. If you take care of them, it's a long life cycle. You should be able to get hundreds and hundreds of cycles off of it, but it's not in the same ballpark as a metal mold. If someone designs the mold, will you program it and make it? Potentially, Harrison. That's what I'm doing. That's largely what I'm doing with Conrad. He designed those molds, and then I made some changes and machined them. But that was more of an ongoing thing. I'm making molds regularly for him. And so we were able to collaborate more on that. I have found when I have seen files that other people have tried to send me, if they don't have their own machine and they don't have the machining chops to do it on their own, oftentimes the files that they send me are so not ready to cut that it's more time than it's worth for me to try to spend time cleaning up their file than it would have been for me to build it from scratch myself. Daniel Taylor, that's a great question. What can you do to learn the basics? If you don't have a CNC, but you're interested in learning about CNC, what you should do is download Fusion 360, start watching YouTube tutorials, and just start playing around with it. Dedicate some time each week to sit down, not make any holsters, not do anything else, just watch YouTube and do CAD tutorials. Start building some simple shapes. Magazine carriers are a great place to start. Take measurements off a Glock mag, build yourself a rectangular solid, try building up some blocking shapes. Start to get the feel for how CAD works. CAM and machining is a whole nother beast. And until you've got the CAD part down, don't try getting into the machining yet. Clark says HDPE needs to be cooled mid-process. Yeah, aluminum can take the heat of press cycles back to back to back to back to back, basically indefinitely. HDPE cannot handle those temperatures. It's too soft. Go to Henry's house and he will teach you. Yeah, no way. Alan Painter says, join late. Brand new holster company with no official company yet. The first few holster molds on my Tormac in right around an hour. That's awesome, Alan. When I was looking at stepping up from my router to my first more serious CNC, I looked at a Tormac and eventually decided against it because it was expensive enough that it was going to eat up pretty much all my available capital, but it was a machine with fairly small travels, and I was confident that I would fairly quickly outgrow it. How do I charge for consulting? Harrison Jones, that depends. Probably the easiest thing is give me a call, 812-369-2266. Tomorrow's not good, but Wednesday or Thursday you can give me a call and give me just a ballpark of what you're thinking about, and then we can see from there. I'm often willing to give as quick and to the point, blunt consulting as I can up front for free. But on some ongoing projects, I do charge for consulting because I have a lot of time wrapped up in them. John Hauptman has been using some 3D printed molds that I had nothing to do with making, but that's totally cool. I've seen some things he's pulled on those, and they do work. 3D printing is an effective way to make certain kinds of things. Yeah, JR, I'll know who to redirect them to. So if you're interested in CNC, first start with the software, because there's a huge learning curve there. You can get the software for little or no cost up front and then invest time ahead of time before you have a machine, because once you pay for a machine and it gets delivered to your shop, it's costing you money. You've paid for it, it took a bunch of money out of your cash flow, and you have to make money with it. So if you can get over the hump, if you can get the learning curve worked out on the software before you get the machine in and you've got stuff ready to go once the machine arrives, that's a much better position to be in. Hello, Tyler. Thank you for stopping by. Facebook comments seem to continue to be working, which is great. I'm glad I restarted it. A few other kinds of accessories you'll have to deal with. The first one is cutters. Cutters on a CNC are consumable. They do wear out and they're easy to wreck. If you take too heavy a cut or you accidentally crash into a clamp or a screw, you can toast a cutter in a big hurry. If you're machining molds, you want a nice clean surface finish, use good carbide. Don't use junk and don't use high-speed steel. I would say for half-inch cutters, expect to spend $35 to $60 depending on what you want. Cook, I would say that you should probably, for a decent above hobbyist grade CNC Cook, I'd be looking probably in the $5,000 to $10,000 range if you're buying new. If you have a chance to get a good deal on a used CNC locally like Clark Trost did, then you can get one for less, but you also run the risk of getting a machine that's been crashed or been damaged or not maintained well. So that's always something to balance. If you are mechanically apt, if you're good at rebuilding machines and you're confident that you can repair, replace, and fix up and tune up anything that's out of whack on the CNC, then it's more reasonable to buy used. If you're not confident in that, you don't have experience there, then buying used really is rolling the dice, and you could end up with a $5,000 or $8,000 machine that never does what you want and you can't figure out. And if you bought it used, you may not be able to get much support on it. Hello, Stephen Baker. So Cook, I would say probably $5,000 to $10,000. Tooling is an accessory. Clamping is an accessory. Dust collection is an accessory. How to actually build the CAD model. Doing it with calipers, radius gauges, takes forever and drives me crazy. Do I recommend 3D scanners? It depends. Alan, I prefer for a lot of my models to do exactly the build you're talking about, which is calipers, good digital calipers, micrometer, radius gauges, angle gauges. And that's how I built a lot of my molds, because Alan, the files are not available for purchase. Pretty much anybody who invests a lot of time up front developing their CAD models is not going to simply sell you files. I don't sell files. I don't think Conrad just sells many files. I don't know for sure, but I'd say you're very unlikely to be able to purchase ready-made files. Certainly can't get them from me. the time that you'll spend getting the CNC dialed and keeping it dialed in is also a time cost. But finishing the accessories. So tooling is one, it's ongoing. You need to stock enough carbide, enough end mills that if you trash one or break one, you're not down for a day or two waiting for a new one to show up. So figure out what you need and buy spares. Conrad, I know, uses a 3D scanner and a pretty high-end computer setup to do all that modeling. I decided not to go that route because I was going to focus more on a core of a handful of models and develop lots of different custom molds out of those, rather than trying to get base 3D scans done of a hugely wide range of models. So Conrad has way more models than I do, but he's also had to spend a lot of extra money to do that, which I haven't had to do. I invested all that money into my milling machine first. He invested earlier on into 3D scanning. And that's two different ways to go about it. Both of them are valid. Either one can work. It just depends on what you're wanting to do with it. Yeah, John, I guess eventually you'll get this J-frame mold you're asking for. We could certainly roll it out in an HDPE version. I'm pretty sure Conrad's got it scanned. Other accessories. Dust collection. A CNC router will make a big mess, and you want to have a way to keep it clean. You don't want chips piling up. You don't want to make a huge mess in your shop, so a good dust collector. A shop vac is not a good dust collector. By good dust collector, I mean high CFM, 4-inch hose that can actually move some volume and pull a lot of chips. Other clamping systems. So I use vacuum clamping on my machines, and the Venturi-based Vac Magic 100 from Mighty Byte that I use. The base pallet system is about $1,500, and then you got to make a bunch of components to go with it. You can rent a 3D scanner and then hit up a well-stocked shop. Harrison, I suppose you could, but there's a lot of work to do to prep the molds. You don't just take a gun and stick it in and hit scan. There's more to it than that. So I don't think the idea of renting a 3D scanner and going and hitting up a gun store is necessarily a good one. Maybe. Yeah, dust collection is really critical. In my mill, I don't have dust collection, but it has a full enclosure, so all the chips stay inside. On my router, which has an open enclosure, I have dust collection and a dust shoe with bristles around it so the chips can't fly out. And I suck everything up through there, through a cyclone, and then into my dust collector to keep all the chips and larger stuff. Clark recommends Harbor Freight. I use Shopfox and Jet. Both of those are pretty dependable for dust collection. Stepcraft Desktop CNC. Chad, I've never heard of it, never even looked at it. My guess is that it's probably mediocre at best. Harrison, back to the issue of 3D scanning. Dark, reflective surfaces, like most firearms, do not scan well unless you prep them. And usually the common preps are talc and white spray paint. And talc or white spray paint. And so usually most gun stores will not let you prep a new on-shelf gun for scanning. Customers sometimes will, but gun stores are unlikely to. Alan, that's a question to ask Conrad directly. I can't answer it for you. I'm not sure. Other possible accessories that may get involved. Depending on what you're building, you might need some probing, like an electrical touch probe, so you can sense in some fixtures, locate some things. If you don't have good digital calipers, you will definitely need them if you're going to get into CNC. You need to be able to take accurate measurements. A dial test indicator with an adjustable stand so you can measure things in is very worth having. If you're going to do CAD and do modeling, a good micrometer, a good set of digital calipers, a good set of radius gauges, and a good angle gauge are critical. I like Mitutoyo. I use Mitutoyo for my mics and my calipers and my radius gauges. Clark says, don't use a small desktop machine. If you really have a very, very limited budget and there's no way for you to get into a more robust machine right off the bat, then a desktop machine might be better than nothing. Patrick, I recommend Mitutoyo for calipers. And then once you've got all that, so if you download a seat of CAD software, yeah, I bet there's lag, John Hopman. If you download a seat of CAD software and you get your calipers, you get your micrometer, you get the tools you need, and you start building some CAD models off guns. You'll usually go through a process where you machine a mold, you make a holster, you test fit, it's not quite right, you mark areas that don't fit. I usually take those initial tests and I gradually jigsaw them into pieces so I can see in and see the fit of the gun to the mold in all the critical areas. And then you will make modifications to the design, you'll update the cam, you'll recut the mold, and you test and gradually walk it in. If you 3D scan, you usually have less revisions to do because you get closer to your final dimensions right away. But there are other issues, other steps that take up time to go from scanned data to a nice, clean, solid model. And scanned data can get some weird artifacts and some weird digital kinks in it. So it's not that building from measurements is the Stone Ages and 3D scanning solves all problems. Depending on what you're modeling, 3D scanning or building from measurements both have their uses. Like if I was building magazine carriers, they're simple enough shapes that I would never bother to 3D scan them. Easy enough to take measurements and just build them. Hello, Jed Harvey. Thank you for stopping by. It's telling me my connection is weak. I think that's weak. Facebook, that's weak. Other things. Time. When you get into CNC, you're not one and done. There are always new things to learn. There are new and more efficient ways to program. You will get better and better and better at getting CAD models drawn up. Clark points out that the scan does not give you a model. It usually gives you a mesh. It gives you a point cloud, an approximation of the shape of the object, and then you have to use that to build your solid model. I have built some of my molds from 3D scans, and I've built some from measurements. Personally, I prefer building from measurements if the shape of the thing that I'm modeling permits it. Yeah, one of the key conceptual things to get through your head when you're talking about CNC machining molds for holster making is the mold needs to have the barest minimum of details to make the holster function. Anything beyond that is just adding unnecessary complexity. It's going to increase your CAD time. It's going to increase your cam and machining time. And the more surfaces, the more notches, the more serrations, the more buttons, the more everything that you include into the mold, the more likely you are to have inconsistencies, snagging, dragging. One of the main things that I do in CAD modeling is I delete any detail that I don't absolutely need. Some guys are really interested in learning CNC, and some guys just want good molds. If you just want good molds and you want them soon, and you don't want to have to go through the big learning curve and the additional expense of getting the machinery and getting it dialed in and using it, then this is a golden era for buying for buying molds for guns and mags. 5 years ago, nobody was selling CNC. 2 years ago, nobody was selling CNC machine molds to holster makers. Any shops that had them were hoarding them like there was no tomorrow. Yeah, I think it is a common misconception, Conrad, that if you scan, you just scan and then boom, you're ready to machine. And there's a whole bunch of steps in the workflow in between getting the scan and then having a model that's ready to cut on a CNC machine. And so this is mostly on the tooling side. So molds and fixtures for making them, that's all tooling. When it comes to actually making products, you can cut, you can drill, and you can engrave actual holsters with a CNC. You'll have to have a way to hold them still in exactly the same place every time so your trim paths are consistent. And I want to get into fixturing and trimming real quick. So here are a few ways that you can fixture and trim thin plastic parts like holsters. The first one is double stick tape, double-sided tape. Carpet tape, wild tape, there are a number of tapes on the market that are designed for this kind of application. The trade-off is it takes time to set them up, it takes time to get your part back off, and then you have to clean the tape off. If you actually cut through the tape with your CNC, it can gum up your bit, start collecting chips, cause a mess. It can even break your end mill if it gets real bad. So tape can work, but it's not a good solution if you're going to do a lot of the same thing over and over. You can hold down with screws. So if you have an inside the waistband holster, and you've got holes below the trigger guard on either side, if you drill those by hand, then you can put the shell down on a fixture on your CNC and put machine screws through those holes to secure the shell in place, and then you can trim all the way around the outline of the holster and get a full, complete cut, and then you just take the screws out and lift the shell off, put the next one on, put the screws in, and trim. The trade-off is then those holes are being drilled manually, not by CNC. So they could be a little bit out if your drill press is out of whack or you're just making a mistake at the drill press. One of the other options is clamps. A common use is toggle clamps. I know the guys at Tulster Holsters are doing this, where they have they use a non-membrane former. They vacuum a single mold at a time, so it's got a large flange of waste material around it. They lay it on their machine. They have a toggle clamp which they snap down at each corner, so the part's basically being held at four corners, and then you're trimming around the shape. If you're holding on the waste material outside the final shape, you can't fully trim the shape out. Otherwise, that middle part will break free and come loose and will probably get into the bit and get ruined. So what's commonly done is tabbed cutting, where you leave a connecting piece of plastic. You basically cut, and then every once in a while you hop over a little section and leave a little connecting tab there, so that when you finish your cut, the actual holster shell is not loose in the middle. Tabbed cutting works fine. The trade-off then is you have to go back and clip those tabs manually, usually with pliers, and then you have to polish in, you have to buff in and polish in that edge. You don't get a completely machined outline in one shot. The trade-off is, if you're holding on the waste material outside, you can drill all your holes and cut your outline all in one operation. Depending on how many holes you have and the shape you're cutting, that can be a good solution, but it also requires you to have a fairly large area of waste material around the part in order to have room to get your clamps down and still have room for the bit to pass by without trying to cut into the clamps. Because, Mick, I don't know if everybody else's is freezing up. It's not giving me a weak connection warning right now. Clark, that trick of using 2 layers of masking tape and then CA glue might work. That sounds time-consuming to me. Bad freezing for you, says Jed Harvey. Man. I don't know, guys. It's not giving me a weak connection signal now, so I'm just going to keep on keeping on. So depending on what you're doing, there are a bunch of different fixturing options. You can also fix your parts in place with vacuum, but you have to have a 3-dimensional jig that fits under the part and nests tightly, and then you have to have some kind of compressible material underneath the shell that can form a gasket so you actually get a tight seal and vacuum. If you have the right kind of fixtures built, vacuum is the best solution because you lay the part in place, you can drill and trim with no tabs all at once. There's no clamps to mess with. It's super fast. You just lay it down, engage the vacuum, trim, drill, disengage the vacuum, blow the chips off, pull it off, next part on, vacuum, and run. But the setup time to actually get that system functioning, to get all the vacuum accessories working together, it's a heavier cost up front. If you're making lots and lots and lots of parts and you're going to have that vacuum fixture in use 5 days a week, then it's probably worth the upfront cost. If you want to be able to do 2 of these and then change and do a couple of those and then do 5 of these, and you're going to be changing over what you're doing on the machine all the time, vacuum might not be the most efficient way for you to set it up. So you have to look at your shop and your realistic volume. Obviously, the higher volume you're going, the more sense it makes to spend money and time up front developing a more efficient solution. If you're making 400 holsters a week, spending an extra couple days investing in a system that shaves an extra 2 minutes off each holster will pay itself off so quickly if you're using it 400 times in a week. If you're doing 10 or 12 holsters a week, spending a day or 2 on fixturing is probably not going to be a good return on your investment right away. It may be down the road, and as your volume increases, you'll recoup that time, cost, but it isn't necessarily upfront. So you're always trying to find a balance of What the next step is you can reasonably get over. I would never recommend that somebody with no CNC experience goes out and mortgages their home to buy a big expensive CNC because you're just not ready for it yet. So the same way that some guys started with foam and then got into coffee bun presses, then got into membrane forming, and are now getting into non-membrane forming, you can do the incremental investment where you upgrade your process a little bit and then use the money, additional revenue that generates to make it up to the next step. Or you can decide, if you know clearly what direction you want to take your business in terms of what kinds of products you want to make, what range, how many different models you want to offer, who you want to sell to. If you have a clear vision for where you want to go with the business, then you can look more carefully earlier on at exactly the solutions that are going to work best for you when you get to where you want to be, and then skip the intermediate stuff that's a halfway solution and go right to the end game. Get to the solution that will do what you want, the way you want from the get-go. That can actually be a much better use of your money. Even though it may be more expensive up front, the buy once, cry once rule is in effect here. So you've got your initial machine, you've got accessories like tooling, you've got dust collection, you've got software like Fusion 360 is a yearly subscription. So after you get your first small CNC and you make your first $150,000 a year of sales because you're killing it with your first CNC, once you're over the $100,000 mark, your yearly subscription to Fusion 360 gets a little more expensive, but it's still very reasonable compared to the other CAD solutions on the market. I haven't seen a comment in a minute or two. Can't tell if it's frozen or not. If you have questions, go ahead and post them up. I'm going to go ahead and go back and like a few comments while I'm at it, and then talk about a couple more things related to CNC workflow, and then wrap it up for the night. So if you're going to make molds on your machine and you're also going to trim parts, that will usually involve some different kinds of cutting tools. I use very different end mills for trimming than I do for mold making. And this has to do with what you're actually cutting. If you have an inch thick block of HDPE or Ren shape or some other hard material, and you've clamped it down or you've screwed it down to the table and you're milling in it, that part's not very flexible. It's not going to move around a lot. And you really want the bit to pull the chips up and out of the cut and get rid of them. And so you'll use typically 2 or 3 flute carbide end mill with a right hand, what's called a right hand spiral or an up spiral. So that as it cuts in to the material, the spiral goes up and the chips are lifted up the gullet and out of the cut. If you're trimming parts, especially trimming holsters, Kydex is very thin and flexible. And so if you're clamping the holster shell down and you're trimming through it and your bit is trying to pull up, the part will flap and chatter on the table and you'll get kind of a nasty, messy edge. You won't get a nice, clean, smooth cut on the edge. And so for trimming, I prefer what are called down spiral or left-hand spiral end mills. My favorites are from a company called Onsrud, and they're called O-flute down spiral. They have a single tooth, so a large open gullet to clear chips through. They're very highly polished, and they spiral the opposite way. So as you're cutting through the part, they're actually trying to push the chips down, which means they're also pushing down on the edge of the holster, and they're not going to make it lift and chatter. They're pushing it down against the table and holding it more still. The trade-off is they are actually pushing the chips down, and so you have to do a little more work to prepare your fixture so you've got a channel for the chips to clear down into, because if you try to just drive them straight into the table and there's nowhere for them to go, they'll pack in the cut and you can have some problems. But for making molds, I like spiral upcut bits. For trimming parts, I like spiral downcut bits. Generally, for the kinds of materials we're working with, 1, 2, or 3 flute end mills are great. 4, 5, anything more than that is not good, especially for materials like HDPE. If you have a lot of flutes, it'll be much easier for them to clog up and load up and you to just get a big wrapped up hot nasty mess of plastic on the end of your end mill. And that doesn't make for clean cuts, and it does make for broken end mills because the chips can't clear out, the end mill loads up, it can't cut anymore, you just start rubbing, you start melting, the end mill heats up, and then you snap it off. Not fun. So It looks like my comments are probably frozen up again. I am sure that there are some questions that I missed when they were scrolling by, so I'll go through. As usual, I will respond in text to any comments or questions that I did not get a chance to answer in the live feed. If you have questions, please continue to post them up here. I will go through and read all the comments right after this. And then we will have another Facebook Live video on CNC, batting cleanup, answering any other questions that have come up. Little plug, Swift presses are in stock. I shipped the first round today. I'm shipping more tomorrow because I had some orders today. If you're thinking about getting into non-membrane forming, I think the Swift press is a great option. It's purpose-built for holster making by a holster maker. It's a nice size. You can get 2, 3, 4 molds onto it if you lay them out right. And that means more holsters per hour. That means less waste material once you start putting multiple molds on, and it means a better use of your time. If every press cycle makes you 4 shells instead of 1, at the end of the day, that's money in the bank. So I have a number of presses left. They are available at henryholsters.com/products/Swift press, or if you just go to the Henry Holsters page, click the blue button, and it will take you right to the Swift press. They're $425 shipped in the continental U.S. And I'm now also including an extra fitting, push-to-connect fitting that will thread directly into the body of a Robinair 15800 pump, which is what I recommend you use with the Swift press. So thank you for stopping by. Please post up your questions. I will go through all the comments. I appreciate you spending your Monday evening with me. Have a great night, guys.